Among the valuable cargo carried aboard the Dragon, a scientific instrument called the CATS, Aerosol Transport System, that is currently housed in the trunk of the Dragon. That's the acronym for the Cloud Aerosol Transport System. That is currently housed in the trunk of the Dragon. Early Friday morning, another robotics operation will be underway where the Special Purpose Dexterous Manipulator, or the Dexter, will remove the CATS scientific instrument from the trunk of Dragon and hand it off to the Japanese robotic arm for its installation on the external experiment platform on the outside of the Kibo module, where the CATS will begin its checkout and operation to measure the layer of aerosol components in the Earth's atmosphere. Other items inside Dragon in the so-called pressurized cargo of the Dragon inside will be unloaded in priority fashion, including the most critical science experiments unloaded first for their installation and activation in various racks in the modules of the International Space Station. And part of the cache of cargo within the Dragon itself, a variety of hardware for the spacewalks that are coming up between February 16th and 25th. 3 spacewalks in particular scheduled by Barry Wilmore and Terry Virts in U.S. spacesuits out of the Quest airlock of the International Space Station that will begin the process of rigging the cables and the communications equipment for commercial crew vehicles that will be arriving at the International Space Station for dockings to specially fabricated international docking adapters, the first of which is to be launched under current planning on the SpaceX 7 mission this summer. That first international docking adapter will be attached during a subsequent spacewalk and a future expedition to the pressurized mating adapter number 2, the docking port that used to be the port of call for space shuttles at the forward end of the Harmony module on the U.S. segment of the International Space Station. Here in the flight control room of the Orbit 2 team of flight controllers, now under the direction of Royce Renfrew, the flight director who's standing up. To his right is spacecraft communicator Josh Matthew, as they are awaiting the crew on board the station to set up a variety of cameras that will be used for this installation process. Once again, the robotics officer here in Mission Control will remotely maneuver the Dragon spacecraft into a perfect alignment between the 2 common berthing mechanisms, one on the forward end of Dragon and one on the Earth-facing port of Harmony, so that a series of ready-to-latch indications are received by the crew on board. At that point, the bolting of Dragon can begin, a series of 16 bolts, 4 gangs of 4 bolts apiece, and once we arrive at second stage capture, Dragon will be hard-mated to Harmony, and today's major activities will have been completed. Throughout the course of the overnight hours this morning, Dragon arrived at all of its key positions on the road to rendezvous a few minutes ahead of schedule, and that permitted the ultimate grapple of the Dragon over the Mediterranean Sea to occur 18 minutes ahead of schedule at 4:54 a.m. Central Time, 5:54 a.m. Eastern Time, which was just a few minutes after sunrise. All of the rendezvous maneuvers for the Dragon occurred on time or ahead of schedule. The SpaceX flight control team in Hawthorne, California, operated in tandem with the flight control team here in Houston every step of the way, coordinating all of the polls of their flight controllers for the go, no-go for a final approach and all of the burns that preceded that point in time. We're expecting to regain our communications with the International Space Station, including our downlink television capability, just a few moments from now, at which point we'll pick up in the procedures to complete the final movements of Dragon towards its pre-install position right at the Earth-facing common berthing mechanism on the Harmony module. You're looking at the two berthing mechanism interfaces just a few feet apart from one another, with Dragon's common berthing mechanism at the bottom and, of course, the space station's common berthing mechanism at the top.
Houston on 2 for VCTV. Appreciate some ESPN, if that's all right.
We'll get it in work, Butch.
And the robotics officer here in Mission Control reports that the Canadarm2 is once again in motion to bring Dragon ever closer to the common berthing mechanism on the Earth-facing side of the Harmony module. The Expedition 42 crew aboard the International Space Station, led by Station Commander Butch Wilmore of NASA, who was launched 109 days ago, along with Russian cosmonauts Elena Serova and Alexander Samokrutyaev. For the other 3 crew members on board the station, This is the 50th day in space for Terry Virts, Samantha Cristoforetti of the European Space Agency, and Russian cosmonaut Anton Shkaplerov.
Station Houston on space to ground 2, no response required. We believe ESPN should be viewable.
Dragon's common berthing mechanism moving ever closer to the common berthing mechanism interface on the Harmony module of the International Space Station. And as you heard from spacecraft communicator Josh Matthew, sports never sleeps on board the station either, as Station Commander Butch Wilmore will get caught up with some of Sunday's sports events through uplink of video provided to the crew as they keep abreast of activities back on Earth. The International Space Station currently flying 262 statute miles above the Tasman Sea, moving from southwest to northeast, about to pass directly over Tasmania and just off the southeast coast of Australia on this orbit of the Earth, as we are standing by for the ready to latch indications as the two common berthing mechanisms, one on the forward side of Dragon and one on the Earth-facing side of Harmony, come into symmetry with one another. This is an intricate and very meticulous process to align the two common berthing mechanisms so that they are in sync with one another. Once the robotics officer receives the ready-to-latch indications along with the operations and support officer, that's the mechanical systems officer here in Mission Control, we'll be hearing that relayed to Flight Director Royce Renfrew, and that will set the stage for the start of the bolting of Dragon in place on the Earth-facing port of Harmony. The mechanical systems officer here in Mission Control reporting that everything is looking just fine as the slow and deliberate installation of Dragon onto the common berthing mechanism continues. The crew had been running ahead of schedule as well as the rendezvous procedures throughout the course of the morning, so there's plenty of time to get Dragon latched up here. This is Mission Control Houston. Some 2.5 hours now since the grapple. This is Mission Control Houston. So my station commander Butch Wilmore, who was joined in the station's cupola by European Station Commander Butch Wilmore, who was joined in the station's cupola by European Space Agency Flight Engineer Samantha Cristoforetti during the rendezvous and approach of Dragon. Wilmore, 54 a.m. Central Time, as Dragon at 2 statute miles over the Mediterranean Sea. Now the arm back in motion again, this time under the direction of the robotics officer here in Mission Control. Moving Dragon, the final, the station flew some 262 statute. Now the arm back in motion again, this time a few inches into what is called the ready to latch position.
And Butch, I've got some words on the printer. We'd like to go ahead and get the black ink cartridge swapped, and I can give you a... And Butch, I've got some words on the printer. We
know where it's at. So swap out the black ink cartridge. Got it.
And Butch, let me give you the rest of it. Let us know when you've done that. We're going to go ahead and command off the printer for about 30 minutes. We'll let you know when it's complete. We'll print a test page, and then let you tell us how it looks.
Trust me, you don't have to worry about us going hands on the printer because it hadn't been working, so we've been blowing it off. So we'll definitely be hands off.
Copy. Just give us a call when you're done with the swap.
Will do. Will do.
Moving Dragon into the so-called ready to latch position, puts it in perfect alignment. Its common berthing mechanism will be in alignment with the active the latching and the bolting of the Dragon to the International Space Station. Once the berthing mechanism that controls the latching and the bolting of the Dragon latch indicators are received here on the ground. Ready to latch indicators are received here on the ground and reported to Flight Director Royce Renfrew by the Mechanical Systems Officer here in Mission Control. Will be set for the start of the bolt. Dragon in place. 4 sets of 4 mated to the Earth-facing port of Harmony. In first stage capture, followed by second stage capture to enable Dragon to be hard mated to the Earth-facing port of Harmony.
In Houston, we have changed out the printer cartridge, and it. In Houston, we have changed out the printer cartridge, and it coughed and sputtered for a while, and finally it stopped, and it has a steady green light, so it's all yours. Coughed and sputtered for a while, and finally it stopped, and it has a steady green light, so it's all yours.
Okay, Butch, copy. The old cartridge can be trashed, and if you could have Sam give us a call before she heads back to Columbus, we had a quick thing for her.
Will do.
Done with lunch before she heads back to Columbus, we had a quick thing for her.
Will do. I think she's ready to call me.
Hey, Sam, before you headed back to Columbus, we needed the CCP command switch to off, OFF, per the execute note on your 1510 activity.
She's ready to call me.
Hey, Sam, before you headed back to Columbus, we needed the CCP command switch to off, OFF, per the execute note on your 1510 activity.
Okay, that's some work.
That call from spacecraft communicator Josh Matthew to the crew on board the station indicating that the robotics officer here in Mission Control continues to very steadily and methodically move Dragon in to the ready to latch or RTL configuration, the position that will enable those indicators to set the stage and alert the crew that is here shortly, followed by the start of the bolt-facing port of the Harmony module would be set to begin. So we're expecting to get those indicators, and again, that bolting will come in two primary stages, a first stage capture, followed by 4 gangs of 4 bolts apiece to form a hard mate between Dragon and Harmony. To catch its breath before it begins the internal work to prepare for the hatch opening of Dragon. That breath before it begins the internal work and the setting up of the vestibule, the tearing down of the common berthing mechanism controller panel assemblies that control the operation of the bolts that are driven prepare for the hatch opening of Dragon. That would involve leak checks at the interface between harness packed off at the time that Dragon will be released, and of the bolts that are driven into the stage will be set at that point for the opening of the crew could elect to wait until the first item right out of the box in the wee hours on Tuesday morning. Harmony and Dragon and the stage.
Station Houston on Space to Ground 2 for Butch for CBM.
Houston, go ahead.
Hey, Butch, the maneuver to RTLs is complete. We've got 4 good ones, so we'll go for first stage capture, which would be you picking up in your activity at 1340. When you get that procedure up, I had a little overview of the latching sequence I wanted to give you before we got started.
Stand by. All right, Houston, I've got 1.522 up and ready.
Okay, Butch, I wanted to direct your attention down to step 5.2. Just a reminder for you as we get into moving the latches that the grayed out steps will be done by Mr. Rob Green here on the ground to get that command sent up to you. That'll light up the command yes execute light for you, so you'll be able to hit that when you're ready to go through the different stages of the capture, and then you'll be waiting on us for just a minute while we send the next one, and that's the sequence that will play out to get ourselves a good capture on the latches.
Okay, and what console runs this again? Refresh my memory. OSO. Okay, we'll go with OSO, and we'll hammer this thing out. And I'm ready to start when you guys are.
Yeah, Butch, we're ready, so you can pick up in step 1.
Step 1. Here we go.
This is Mission Control Houston. Josh Matthew tagging up with Station Commander Butch Wilmore at the start of the bolting operations now that will take place since Dragon's common berthing mechanism is now in perfect alignment with the active common berthing mechanism on the Harmony module at the International Space Station on the Earth-facing side of Harmony. The OSO console that was referenced there is the Operations and Support Officer here in Mission Control, essentially the Mechanical Systems Officer in charge of all of the various mechanisms on the International Space Station. In this case, the common berthing mechanism is the apparatus that Dragon is being bolted to. There'll be a 2-phase approach to this. You'll hear first stage capture initially, followed by second stage capture, and at that point, Dragon will be bolted to the Earth-facing port of Harmony. The robotic arm that latched on to the Dragon cargo craft at 4:54 a.m. Central Time, 5:54 a.m. Eastern Time to complete its 2-day rendezvous will be backed away, and it will be configured back into its normal quiescent orientation with its job having been completed.
Unicorn 2, I'm back with you for Cubic.
Go ahead on 2, Samantha.
Statute miles above the Pacific Ocean, moving from southwest to northeast, soon to cross the west coast of the United States directly over Portland.
Making sure that you're good with continuing past step 3.
And Butch, we got a handover in 10 seconds. Attitude control is good. We'll give you a go for step 4 once we have comm back.
Okay, sounds good.
Once we complete the handover between our tracking and data relay satellites here and regain communications, the robotics officer here in Mission Control will place the Canadarm2 in the so-called limp mode, essentially ensuring that the arm does not execute any uncommanded motion that would disrupt the bolting of Dragon into place in a smooth and methodical manner.
We're ready for step 4 and first stage capture.
Houston, copy, picking up in step 4.
We're with you and ready.
And the mechanical systems officer reports a good first stage capture. Wilmore sending commands for the bolting of Dragon into place on the Earth-facing port of Harmony through a laptop computer on board the station.
Houston, at the end of step 4, I think we are go for SSRMS mode to limp.
Butch, we see the same. We agree, and give us just a minute, and Robo will get that in work.
Copy, standing by.
Commands now being sent to limp the Canadarm2 robotic arm. that was used 3 hours ago to capture the Dragon as it passed over the Mediterranean Sea at an altitude of 262 statute miles. You see the station and Dragon approaching sunrise. Currently flying over southern Saskatchewan. The arm is now limped, and the green light being given to Wilmore for second stage capture that will firmly bolt Dragon in place.
5.1.
Outstanding. Thank you. Picking up in 5.1. And Houston picking up in 5.2.2.
We copy and we're ready.
Houston, are you already ready for 5.3.2?
That's affirmed. We are ready.
That came a lot faster than I expected. Okay, here we go. Here we go at 5.4.2.
We are ready.
Okay, Houston, I am in step 5.5. Supposed to check you for CBM latch stall recovery. Arm steps are done.
And Butch, we're happy with the values, so step 5.5 is not required. We're ready for step 6.
I was hoping you would say that. Sounds good. Here we go, step 6.
This is Mission Control Houston at 7:54 a.m. Central Time, exactly 3 hours after it was grappled following a 2-day rendezvous after its launch from the Cape Canaveral Air Force Station in Florida. Dragon now an official part of the International Space Station, having been bolted into place. Second stage capture confirmed at 7:54 a.m. Central Time, 8:54 a.m. Eastern Time, as the International Space Station flew over Quebec, Canada. The cleanup steps are in work now by Station Commander Butch Wilmore, but Dragon now has been bolted into place on the Earth-facing port of the Harmony module of the International Space Station. So the leak checks can begin now over the next several hours by the crew. They will also be outfitting the small vestibule or passageway between Dragon and Harmony to set the stage for the opening of the hatch to Dragon that will take place either late today or first thing Tuesday morning, in the wee hours Tuesday morning, depending on how the rest of the crew day unfolds. So once again, to recap, Dragon now part of the International Space Station. It will be housed at the Earth-facing port of the Harmony module of the station for the next 29 days until it is unbolted, unberthed, and released on Tuesday, February 10th, to begin the journey back to Earth that will culminate with a return of supplies and critical scientific experiments with a splashdown in the Pacific Ocean southwest of Long Beach, California, in the late afternoon of February 10th. So that'll wrap it up for our activities this morning. Once again, Dragon completing a textbook rendezvous to reach the International Space Station, grappled at 4:54 a.m. Central Time, and 3 hours later at 7:54 a.m. Central Time, bolted into place on the Earth-facing port of the Harmony module. We'll have a complete recap of all of the activities that occurred overnight with the arrival of Dragon at the International Space Station on Space Station Live, that is coming up in just 2 hours at 10 a.m. Central Time, 11 a.m. Eastern Time. For now, Dragon safely bolted into place at the International Space Station. This is Mission Control Houston.
Hey, this is Larry the Cable Guy, and somebody as educated as I am, where do I turn to? NASA TV! Get her done!
The next time you look up at the night sky, just think. Each point of light is a sun, and likely has orbiting planets. In fact, astronomers searching one small sliver of the sky have found nearly 1,000 worlds so far. We're surrounded by solar systems. And as we learn more about the universe around us, NASA is developing capabilities on Earth and in space to send astronauts further into our solar system than ever before, to an asteroid, Mars, and beyond. To follow the journey as NASA expands human presence beyond Earth, visit nasa.gov.
Hi, I'm Peter Cullen, and you're watching NASA TV.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the SpaceX Falcon 9 rocket with Dragon, continuing the resupply chain to the International Space Station.
Towers.
Pitch kick is in.
OSMGC proceed to section 10.63.
Stage 1 propulsion at nominal. F9 power, 23 dollars. T plus 60 seconds, altitude 5.5 kilometers, speed 250 meters per second, downrange distance 0.9 kilometers.
Stage 1 propulsion continues to perform nominally. Vehicle supersonic and has reached maximum aerodynamic pressure.
F9, power and telemetry still nominal.
Landing platform has received acquisition of signal.
MVAC has begun chill. Altitude 35 kilometers, speed 1 kilometer per second, downrange distance 14.5 kilometers. T plus 2 minutes 30 seconds. Altitude 58 kilometers, speed 1.8 kilometers per second, downrange distance 33 kilometers. And we have MECO 1.
Stage separation confirmed.
And we have second stage ignition. Altitude 90 kilometers, speed 1.9 kilometers per second, downrange distance 67 kilometers.
We like to pick a company that's going to be, one, representative of small business, but will give us an opportunity to showcase something that you're not going to see every day. And Bally Ribbon is just that kind of company. It's a very, very, very unique company that's providing for us a very unique product. This is all about technology development. That's the way you do it. You get ideas not from people like me. You get them from the people on the ground who do this stuff every single day.
looks like you're on the other side of the room.
Yeah.
It's like, you know, so, like, no.
I already shot it.
It's already shot. I've gotten that with pictures. Sometimes they look like an apple. Russian pads made out of quartz.
Right.
Like the 3-inch. Yeah.
Right.
Forklift operator to receiving.
T-minus 12 minutes.
Timer.
Sam, ready. FACA.
Bring nicely from the initial launch transients. Main engine control is good. Vernier control is good. We have separation command. Separation.
SMAP is trying to improve our ability to understand how water availability is changing over different regions of the Earth. The amount of water the Earth holds is constant, but some areas may receive more water, some areas may receive less water. SMAP will help us improve our ability to forecast where those regions are and to perhaps take action to mitigate the effects of either too much water or too little water. One of the more interesting features of the SMAP satellite is the large spinning antenna that's used by the instrument to make its measurement. The antenna needs to be large in order to have high resolution. It needs to spin because the antenna is looking off at an angle, and we rotate it so that it sweeps out a circle underneath the observatory, which allows us to measure a 1,000-kilometer wide swath under the satellite. That 1,000-kilometer wide swath allows us to measure the entire globe every 2 to 3 days. Water is fundamental for human life, and SMAP will allow us to track how future water availability in different regions of the Earth will change, and that's going to affect the lives of every person on the planet. Being able to understand that in advance, accurately, reliably, will be invaluable for a number of different uses that will benefit everybody on the planet. SMAP stands for Soil Moisture Active Passive. Soil moisture is measured over the entire globe every 2 to 3 days. We use an active radar to measure soil moisture with high resolution. We use a passive radiometer. It's a simple scientific receiver to measure soil moisture with high resolution. So with both the radiometer and the radar, we're able to get both high resolution and high accuracy in one single instrument.
The moisture in the soil governs a lot of things. First of all, it's the layer that controls the evaporation of water into the atmosphere. That moisture can be distributed in the atmosphere, form clouds and rain, so it's an important part of the land water cycle. It's also a precursor condition for predicting floods. It also is the soil layer where crop roots are, so it governs the crop yields. So there's many applications of soil moisture that are important. One of the most important applications is improving our ability to predict weather and climate. The soil moisture conditions at the surface are important for initializing weather models that predict future rain and temperature. The soil moisture is also very important in improving climate models that can help us forecast longer range conditions of drought and conditions of atmospheric temperature and precipitation in seasons to come. So these are applications that the operational agencies, not just in the United States but globally, can use these new measurements to improve their forecasts. SMAP is a research mission. It's the first of its kind for this high spatial resolution soil moisture measurement. I think it'll be very important in applications worldwide, as I've mentioned, floods, droughts, agriculture, and weather and climate prediction. I think that the use of this new data type will really enable a lot of benefits globally, which are very important and exciting. I'm very excited about it. It's been a long time coming. Many of us in the research area have been working on soil moisture for a long time. We're very excited about the new data type and working with colleagues around the world to make the best use of it. And we think it's going to have a big impact on our knowledge of the water cycle.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the SpaceX Falcon 9 rocket with Dragon, continuing the resupply chain to the International Space Station.
Towers.
Pitch kick is in.
OSMGC proceed to section 10.63.
Stage 1 propulsion at nominal.
F9 power and telemetry on.
T plus 60 seconds, altitude 5.5 kilometers, speed 250 meters per second, downrange distance 0.9 kilometers. Stage 1 propulsion continues to perform nominally. Vehicle supersonic and has reached maximum aerodynamic pressure.
F9 power and telemetry still nominal.
Landing platform has received acquisition of signal.
MVAC has begun chill. Altitude 35 kilometers, speed 1 kilometers. T plus 2 minutes 30 seconds. T plus 2 minutes 30 seconds. Altitude 58 kilometers, speed 1.8 kilometers per second, downrange distance 33 kilometers. And we have MECO 1.
Stage separation confirmed.
And we have second stage ignition. Altitude 90 kilometers, speed 1.9 kilometers per second, downrange distance 67 kilometers.
We like to pick a company that's going to be, one, representative of small business, but will give us an opportunity to showcase something that you're not going to see every day. And Valley Ribbon is just that kind of company. It's a very, very, very unique company that's providing for us a very unique product. This is all about technology development. That's the way you do it. You get ideas not from people like me. You get them from the people on the ground who do this stuff every single day.
Like, you know, so, like, no. held it, it looks like you're on the other side of the room.
Yeah. I already shot it.
It's already shot. I got
Forklift operator to forklift operator to receiving.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And liftoff of the SpaceX Falcon 9 rocket with Dragon, continuing the resupply chain to the International Space Station.
Towers.
Pitch kick is in.
OSM GC proceed to section 10.63.
Stage 1 propulsion is